Begin by checking the glassware, ensuring that all the glassware listed on the box is present and in good condition. If anything is missing or broken, just ask a member of staff and we'll replace it with any item you need. Begin by labelling two 100 ml beakers for the sodium buffer and the potassium buffer, and decant approximately 50 ml of each into each beaker. Then label a smaller 25 ml beaker for bromothiamyl blue and decant in or around 15 ml of bromothiamyl blue into the smaller beaker. Next, you need to prepare the 12 25 ml volumetric flasks. The first two volumetric flasks need to be labelled HIN and IN-. The remaining 10 flasks will be labelled 1 to 10. Next, you need to prepare your HIN and IN solutions. Before you begin, remember how important it is to rinse all glassware with deionized water before use. This step must be repeated for all volumetrics in this experiment. The next step of the experiment involves making up your two solutions of HIN and IN-. Before you begin making up these solutions, it's important to remember that all glassware should be rinsed with distilled deionized water before use. And this step needs to be repeated for all volumetrics in this experiment. Begin making your solutions by pipetting 1 ml of the bromothiamyl blue solution into each of the two volumetrics. Then add 12 drops of the conc HCl solution. Now dilute the solution to the mark with distilled water. Invert a number of times to ensure the solution is fully homogeneous. To prepare the IN solution, add 5 centimeters cubed of distilled water, and then 12 drops of the 4 molar NaOH solution provided. You should note a colour change. Dilute the solution to the mark with distilled water. Next is to prepare the series of bromothiamyl blue solutions which have different pHs. Using a pipette, you will transfer 1 centimeter cubed of bromothiamyl blue into each of the flasks that have been pre-rinsed with distilled deionized water. Once you have placed 1 centimeter cubed of bromothiamyl blue into each of your 10 volumetrics, you now need to add the sodium and potassium buffers. Begin with your potassium buffer, placing 5 ml into flask number 1. 10 mils into flask number 2, 5 mils into flask number 3, 10 mils into flask 4, 5 mils into flasks 5 and 6, and 1 mil each into flasks 7 and 8. Until now, with the larger volumes, it's been perfectly accurate and acceptable to use the graduated cylinder, but for the smaller volumes, it's much more accurate to use a pipette. After rinsing the pipette with deionized water, you can rinse it with some of the solution it's due to contain, in this case, potassium buffer. And finally, draw up 1 mil of your potassium buffer before placing it into volumetric flask 7. Repeat and add 1 mil into flask 8, and finally 0.5 of a mil into flask 9. You won't be adding any potassium buffer into volumetric flask number 10. Once you have added all the potassium buffer, as indicated in table 1, to your 10 volumetric flasks, you can proceed with the clean, washed pipette to add the sodium buffer, as indicated in the same table. You will notice that there is no sodium buffer added to flask number 1, and so you need to add 0.5 of a mil into flask number 2. Continue adding all of the volumes as indicated in table 1 to the 10 volumetric flasks. Make up to the mark with distilled deionized water. Now that you've made up all of your solutions 1 to 10, you can see that the colour graduates from a yellow to a deep blue. What you can also see is that solution number 1 is very similar in colour to the highly acidified solution of bromothymol blue, but solution 10 is very similar in colour to the IN-, or the solution where the bromothymol blue is present in a basic solution. Now that all 12 solutions are prepared, they are ready for analysing. Each solution will need to be analysed via 2 different techniques. You will need to measure, firstly, the pH, and secondly, the absorbance values of each solution by UV-vis spectroscopy. In order to start this, begin by removing a small aliquot of the first solution and transfer enough of this solution to fill a small cuvette. Place the cuvette back in the cuvette box and set aside for later. Then pour the remaining solution into a 25 ml beaker and place the small stirring bead inside. Place the beaker on the magnetic stirrer and turn on so the stirring bead stirs at a gentle pace. Remove the pH probe from the buffer solution. Rinse the probe with deionized water and remove the last droplets with the tissue. Lower the probe into the solution and allow the pH meter obtain a steady reading. Record this pH value on your results sheet. Remove the pH probe and rinse well with deionized water. You can now dispose of the sample into the waste beaker, being careful not to lose the stirring bead. The glass rod can assist with this. Wash the beaker, including the stirring bead, with deionized water, and discard the washings into your waste beaker. Transfer the bead into a clean, dry beaker and allow the initial beaker to drip dry upside down. Repeat this process for the remaining 11 solutions. Once you have this stage complete, you should have pH values for all solutions and 12 cuvettes containing the solutions ready to be analysed via UV spectroscopy. At this stage, all used glassware should be thoroughly washed and then rinsed well with deionized water and finally returned to its storage box. The contents of your waste beaker can safely be discarded down the sink. Once your glassware is clean and stored, take a moment to ensure that all the glassware listed on the top of the box is accounted for. Now check the pH probe. It is good practice to always store the pH probe immersed in a buffer solution, and a pH of 7 is preferred. Before leaving the bench, prepare a blank sample of deionized water in a cuvette. You are now ready to take your samples to the UV spectrometer for analysis. This spectrometer is a Perkin-Elmer Lambda 35 that works on a double beam system. This means that a blank sample containing distilled deionized water in a cuvette needs to be placed into the reference compartment. Place the blank into the reference compartment. This will remain in place for the duration of the analysis of all samples, and then close the lid. Once the blank sample is inserted, you need to start the program. This will then request that your first sample be placed into the sample compartment for analysing. Place the sample into the sample compartment and then close the lid, ensuring it is tightly closed. The sample will be scanned between 750 and 300 nanometers. Once the first sample has been analysed, repeat with the all following solutions. There are 12 samples in total to be scanned. Continue until you have data for all 12 samples. Once the 12th and final sample has been scanned, it is now time to review and analyse each of the individual scans obtained. As you review each scan from acidic to basic solutions, you will clearly observe two peaks of interest that correspond to the two absorbance wavelengths for bromothymol blue in acidic and basic solutions. You will need to record absorbance values at both of these wavelengths for each of the 12 samples. While you can review each sample scan individually, it's also possible to overlay and view all sample scans together. Here you can clearly see the two peaks of interest for all 12 samples. Once you have recorded values for both of these wavelengths for each of the 12 samples, ensure you remove any samples left in the spectrometer